In this video, we are going to learn about the relationship between heat, mass and temperature. To know this relationship, let us see an activity. Let us take two beakers, a smaller one and a bigger one. Let us fill both of them with water. The smaller beaker will have less mass of water and the bigger beaker will have more mass of water. They both are at the same temperature initially. Now let us start heating both of them. After a few minutes, for example after 5 minutes, when we measure the temperature of water in both the beakers, we notice that the temperature of water in smaller beaker is more. For example, it may be 50 degrees and the more mass beaker or the bigger beaker will have a temperature of 40 degrees. In that way, there will be a change in temperature. To attain the same temperature for the water in the bigger beaker, you have to heat it more so that the temperature comes nearly equal to 50 degrees, right? Because it has got more mass, it is requiring more amount of heat. That is why we can write Q is proportional to M. To attain same temperature, more amount of heat is required by more mass. So, Q is proportional to M when delta T is constant, where delta T is change in temperature. Change in temperature is obtained from change in temperature minus initial temperature. So, that is the change in temperature. When the change in temperature is constant, that means both the beakers are of same temperature. How is it possible? It is possible only when the bigger beaker is heated for a longer time or more amount of heat is supplied to that beaker, then only both of them will attain same temperature. And let us measure the temperature difference of any beaker with time. For example, let us consider the smaller beaker or the bigger beaker. Whichever you consider, with time the temperature difference is increasing. That means delta T increases with time. So, the amount of heat is increasing and the temperature difference is also increasing with time for a constant mass. The delta T increases constantly. The change in temperature rise is constant with time for a given mass of water or given mass of substance. So, Q is directly proportional to delta T when M is constant. From these two equations, I can write Q is proportional to M into delta T. When I remove the proportionality symbol, I will get a proportionality constant. So, I can write as Q is equal to Ms delta T, where S is a constant for a given substance and it is called specific heat. So, I can write as S is equal to Q by M delta T. The specific heat of a substance is the amount of heat required to raise the temperature of unit mass of a substance by 1 unit. The units of specific heat are, in CGS system, the units are calories per gram degree centigrade, and in SI system, the units are joules per kg Kelvin. The relationship between calorie per gram degree centigrade and joule per kg Kelvin is 1 calorie per gram degree centigrade is equal to 4.2 into 10 power 3 joules per kg Kelvin. In the next video, we'll see problems related to this topic.